Hello everybody, my name is Mark Huelskoetter and I work for the FAA. I want to start off by saying thank you so much for inviting me to speak today at the 44th Annual National Indian Timber Symposium. Today we're going to be talking about drones. The FAA commonly refers to these as unmanned aerial systems, and more specifically, how to become a Part 107 certified pilot. I love talking about drones. It's a technology that has made aviation an affordable and safe proposition for many industries. My background is in law enforcement. During my time with the Anchorage Police Department, I recognized the value of having an aerial asset available, which led me to create the drone program for the department. It was this interest in aviation that led to my current job here at the FAA. In no way am I going to be able to cover everything there is to know about drones. It's something we could discuss over the course of several days. Instead, today we're going to talk about the benefits of using a small UAS, the federal regulations governing small UAS, obtaining your pilot certificate, otherwise known as pilot's license, and what comes next after you've obtained your license. The question is, what makes drones so special? Well, I would argue that it's their ability to place some sort of sensor in three-dimensional space. Before this technology came along, you would have to use an airplane or a helicopter to be able to take overhead photographs of your property. Now you can do this in a much safer way and at a significant cost savings by using a drone. In addition to simple photography, drones can be used for detailed mapping and 3D modeling. From a police perspective, this is a big time and money saver. A drone can now fly overhead of something like a crash scene, take a few photographs, and then use some software to reconstruct that scene into an overhead view and a 3D model. This used to take several officers hours to close down a road while they took measurements by hand, and then they would have to go back and recreate everything on paper. But the benefits of drones don't stop there. They're used in agriculture by the use of multispectral imaging, which allows you to take images of a crop using cameras under different wavelengths, which can help determine the health of crops. They're used with sprayers. They can actually spray crops for insect mitigation. They are also used by multiple agencies for wildland fires to assist in suppression, as they can fly over areas and find hotspots using thermal cameras. Drones have even been demonstrated to be able to help plant new trees in areas that were previously cleared. From the perspective of the FAA, there are two ways you can fly drones. One is as a hobbyist, and the other is as an FAA certificated pilot. I'm going to cover some of the rules for both. I think you're going to find that the rules are very similar. So for a hobbyist, you're only allowed to fly for recreational purposes, your own enjoyment. You must be following the safety guidelines of an FAA recognized community-based organization, something like the Academy of Model Aeronautics. You must keep your drone within visual line of sight or use a visual observer who is co-located, meaning physically next to you, and in direct communication with you during the entire flight. You have to give way and you cannot interfere with other manned aircraft. You're required to fly at or below 400 feet above the ground in controlled airspace, such as Class B, C, D, and E, and only with prior authorization by using Lance or Drone Zone, and that's something I'll talk about a little bit later. You're also required to fly at or below 400 feet in uncontrolled airspace, commonly known as Class G. Coming very soon, you're going to be able to take the Recreational UAS Safety Test, aka TRUST, and you will be required to carry proof of the test passage. You must have your drone currently registered and mark your drones on the outside with the registration number and carry proof of registration with you. This applies to a hobbyist drone that is greater than 0.55 pounds. You're also not allowed to operate your drone in a dangerous manner. For example, don't interfere with emergency response or law enforcement activities, and do not fly under the influence of drugs or alcohol. Now that we've talked about rules for the hobbyist, let's talk about what regulations govern the use of aircraft under Part 107. And to do that, we first must take a look at the aircraft itself. So in order to be considered a small unmanned aerial system, the aircraft must weigh less than 55 pounds. And believe me, at 55 pounds, that would be one large drone. Just like with the hobbyist operator, as a Part 107 pilot, you must keep your drone within visual line of sight. You can use a first-person view or similar technology, but you always must have a visual observer that can keep the drone in view with unaided sight, so they can't use binoculars. Additionally, you can only pilot one drone at a time or be a visual observer for one drone at a time. And when you think about it, that makes a lot of sense. The sky is a busy place, and the last thing we want to have is a drone interfering with the flight of a manned aircraft. When we consider the operating limits of the aircraft, again, just like the hobbyist, the maximum altitude you can fly a drone is 400 feet above the ground level. You may fly higher than that if you're doing something like an inspection of a tower or maybe like a power generation windmill that rises up off the ground, 200 feet. As long as you're within 400 feet of that structure, you can still fly. So effectively, if you're inspecting a tower that's 200 feet tall, you would be allowed to go up to 600 feet AGL. The maximum ground speed for the drone you operate cannot exceed 100 miles per hour. And if you think about it, at 100 miles per hour, it wouldn't take long for that drone to leave your visual line of sight. So that's probably a pretty good rule. The minimum weather visibility to fly your drone is 3 miles from the control station. So you have to basically be able to see for 3 miles in any given direction in order to maintain that situational awareness for any other aircraft that might be operating in the area. Again, we must yield the right of way to any other aircraft that are in the sky. And finally, we should never operate in a careless or reckless manner. A recent update to the rules under Part 107 now allow for operations over people given certain restrictions. But as a general rule, do not fly your drone over people unless they're directly participating in the operation, have been properly briefed, and have the appropriate safety gear. If you want to know more about the changes involving operations over people, you can see Part 107.105 that contains all the cases in which it's appropriate to fly over people. Additionally, do not operate your drone from a moving vehicle or aircraft unless you're flying your drone over a sparsely populated area and it does not involve the transportation of property for compensation or for hire. A recent change with Part 107 is regarding operations at night. Previously, you could only fly during daylight, meaning 30 minutes before official sunrise to 30 minutes after official sunset local time, or in twilight if your drone has anti-collision lighting equipped. Now you may operate at night only after completing either your knowledge test that contains questions regarding night physiology and night visual illusions, or through completion of recurrent training if you're already a pilot. Just like the hobbyist, you must fly in uncontrolled airspace unless you have a waiver. There are a couple of different ways you can obtain a waiver. One of those ways is via the low altitude authorization and notification capability. There are several different service providers which have applications on your mobile device which allow the pilot to apply for quick authorization in areas of controlled airspace if it's supported by LANC. For any more complex operations or areas not supported by LANC, you can visit the FAA's Drone Zone website. It's a one-stop shop for your registration and authorization needs. Speaking of registration, your drone under Part 107 must be registered. In addition to that, hobbyists must register drones if they weigh 250 grams or 0.55 pounds or more. This can be done through the Drone Zone website. Your registration number must be visible on the exterior of the aircraft and is available from the website at a cost of $5. The graphic in the slide shows different ways that you may have your registration on your aircraft. One is by engraving it into the side of it. Another is by affixing a permanent label to it. Or, like I did, I wrote mine in permanent marker on the side of my aircraft. Here are the requirements for obtaining your certificate. First, you must be at least 16 years of age. You must be able to read, speak, write, and understand the English language. If for any reason you're unable to meet one of those requirements due to medical reasons, the FAA may place operating limitations on your certificate as necessary for the safe operation of the small unmanned aircraft. You must also be in physical or mental condition that would not interfere with the safe operation of that aircraft. And you must demonstrate your aeronautical knowledge, which is to pass an initial aeronautical test covering areas of knowledge which are specified in Part 107.73, or if you already hold a pilot certificate other than a student pilot certificate issued under Part 61, and you meet the flight review requirements, all you need to do is complete training covering the areas of knowledge specified in 107.74. You may be wondering what is going to be on the knowledge test. The next couple of slides are taken directly from the FAA's website. So first, you're going to need to know the regulations, otherwise known as Part 107. I encourage you to read all of Part 107 and understand as much as possible. Additionally, you need to have knowledge that other pilots have. So you need to understand airspace classification, operating requirements, and flight restrictions that affect the small unmanned aircraft. Aviation weather sources and the effects of weather on small unmanned aircraft and their performance. Did you know that quadcopters are susceptible to icing? Flying a quadcopter in snowing conditions can lead to ice on the propellers, which can cause it to fall out of the sky. You need to know about loading your small unmanned aircraft. So what effects do changing the payload, maybe swapping out to a new camera, what effects is that going to have on the actual aircraft? You need to know something about emergency procedures. And as a good Part 107 pilot operating out there, you probably are going to utilize at least one visual observer. You need to learn what is good crew resource management, how to communicate with your team members. There will be questions regarding radio communication procedures, determining the performance of the small unmanned aircraft, the physiological effects of drugs and alcohol on the pilot, aeronautical decision-making and judgment, airport operations, maintenance and pre-flight inspection procedures, and operations at night. With respect to the decision-making and judgment, it's going to be incumbent on you to utilize all the resources that are available to you to determine whether or not that particular flight you want to do on that day is a good idea or not. You need to learn those airport operations. It's important to know what the traffic pattern is and how the aircraft in your area are going to be approaching and departing that airport. That's going to prevent you from running into trouble. You may be wondering how to study for the test. Well, you can do it like I did it. I did a bunch of self-study. I learned the regulations. I got the book, the really thick book called the FAR-AIM, which is the Federal Aviation Regulations Aeronautical Information Manual. I also used a mobile application that offered practice test questions and testing. I watched lots of videos on YouTube. There's a ton of people out there that are willing to help you pass your Part 107 test. You can look on the FAA Safety Team website, and a good resource right now is the ALC-677, which is the Part 107 Small UAS Recurrent Training. Once you obtain your certificate, it is good for 2 years, and every 2 years you must become recurrent. The information in that training tells you how to become recurrent, but it will also give you a good understanding of what is going to be in the test. And then there are lots of online resources. There's a ton of vendors out there that offer online ground schools, and some of them even guarantee that you will pass your test. Now that you've studied and are ready to take your test, becoming a drone pilot is basically as easy as 1, 2, 3. All right, well, maybe it's not that easy, but step 1, you need to obtain an FAA tracking number by creating an account on IACRA prior to registering for your knowledge test. That can be done at iacra.faa.gov. Step 2 is to schedule an appointment with the Knowledge Testing Center, which will administer an initial or recurrent FAA knowledge exam. Be sure to have your photo ID with you at the test. And you can find those testing centers by going to faa.psiexams.com. And step 3, pass the test. For me, I spent probably about 40 hours of actual study time. The rest of the time was spent on that mobile app practicing my test questions until I felt like I was ready to take the test. And the test, as it turns out, was surprisingly easy. But after you become a pilot, what comes next? Well, I highly recommend you practice whenever possible. I really encourage you to learn all about your aircraft, understand every aspect of its operation. Start becoming proficient. Start being able to anticipate things that can go wrong and practice that good aeronautical decision making. Next, be safe. Create and use checklists. Practice good risk management. Look at the environment you want to fly. Make sure your aircraft is capable of performing the mission. Make sure there's no weather. And if you don't think you should fly, then don't. And finally, I want you to stay current. All right, as I've mentioned previously, regulations do change. Not much, but they do change. So stay on top of all that. Stay current in your knowledge, and that will help you along the way. I know I just barely scratched the surface on what it takes to become a remote pilot, but I want to thank you for your time. I wish I had more. I could spend all day with you. And maybe next year I'll get a chance to come and do this in person. But in the meantime, here's my contact information. If you have any question, anything related to aviation, don't hesitate. Reach out. All my contact information is there. Anytime, I'd be happy to answer any questions. Thank you so much.
All right, I think we're live. Hi, everybody. My name is Clay Hoyt. I'm a forester for Chugachmute, which is an Alaska Native nonprofit serving the Chugach region, the Lower Kenai Peninsula and Prince William Sound. I'm also a graduate student at Alaska Pacific University. And today I just wanted to give you an overview of one of our exciting projects at Chugachmute using a drone for early spruce bark beetle detection. In South Central Alaska. Before I get started, a big thanks to the Bureau of Indian Affairs for the funding for this project. All right, so what are we doing? Our goal here is to develop a workflow and a tool for early detection of spruce bark beetle in spruce stands remotely with a drone system. It's kind of a mouthful, but essentially what we wanted was something that was easy to use, affordable drone that you could pop up in the air and rapidly get information back on the health of that spruce stand while it's being attacked by spruce bark beetle. Why is this important? Well, spruce bark beetle, it takes a little while to kill a tree. Once a tree is attacked by spruce bark beetle, it starts slowly dying after it's girdled the end of that, middle end of that first season. And it can take 2 or 3 years for you to visually pick up a change in color on that crown from green, healthy to, tinging yellow or orange and very obviously dying, right? And then those trees all have to tip over. And Chugachmute, we staff a Type 2 initial attack fire crew and a small module for hazardous fuels reduction. So a lot of our summer work, we are implementing, those fuels reduction projects or installing fuel breaks. Sterling fuel break is one of our biggest projects. And we want to make sure that when we go in there and we do work, that it's going to be an effective product afterwards. So if we go in there and do some work, this picture on the right, you can see, this is a shaded fuel break, a common prescription for a fuel break. We want to make sure that none of those trees left are going to die in the next couple of years and become a hazard for firefighters or, just add to the fuel loading for a fire. So it's effective fuels reduction treatments is kind of a primary objective for us. If we can develop this tool, it would be great to send out with a fire crew and have them be able to throw it up in the air over a fuel break alignment and bring back the SD card with the data, and I'm able to give them some information on what to look for. This, like I said, it takes years for spruce bark beetle to show up visually, like from the air, like an aerial survey type situation. And it becomes a big problem when you're not planning for a landscape level mortality event, and then you detect it. All of a sudden you're up in there, and as far as you can see, there are, orange needled spruce trees, and they're intersecting a power line corridor, and you realize, oh man, it looks like we have, a year or two before they start falling apart and maybe coming in contact with the power line corridor or campsites, or you name it. The applications are kind of vast for early detection of spruce bark beetle. So moving forward with some background, this is kind of that vast sea of, you figure out all the trees are dying at once. This picture on the right this is sitting in drainage, Little Willow Creek, 2018. But yeah, most of you that have been in South Central Alaska know we are kind of at the tail end of this spruce bark beetle outbreak that's been going on for 4 or 5 years now, 5 or 6 years probably. And it's right now it's working pretty actively on the Kenai Peninsula, marching south. But what we do know from this one and prior outbreaks is that in mature spruce stands, white spruce stands in South Central Alaska, it seems that over 90% of the stand, they die. So this is a huge mortality event, and it's really only mapped when they start changing color, like this picture on the right. For the most part, yeah, a couple seasons, sometimes longer, depending on intensity of attack, to change from a green crown to an orange crown. So that's a little background. I'm sure you guys are familiar with it. Early detection. So I've talked about it a little bit. What is it? I'm going to use this term green attack. It's kind of clunky, but it's easy. And what that means is this is when spruce beetles attack that tree, and that tree still looks healthy, and the crown of that tree is green, and you wouldn't be able to tell from 50 feet away that tree was dying. So that's the green attack I'm talking about. And how do we identify green attack trees right now? It's all boots on the ground effort. You have your foresters or your fire crew walk around, and they inspect the boles or the trunks of the trees for boring dust, sawdust at the base of the tree. And then after attack, as the season goes on, the tree responds and pushes pitch to the entry holes, and you see pitch tubes popping out of these things, and it becomes very obvious. And once you know what you're looking for, it's kind of easy to pick up on the ground. But we're in Alaska, we don't have a robust road system, especially in Alaska Native forestry. So if we want to get a good assessment of spruce bark beetle infection, and we're not close to a road, and we have potentially a large area to do it, it becomes not really feasible. So that's a challenge that we face, and this is where the application with the drone comes in. But how do you pick up a cracked spruce with a drone? By taking pictures. This multispectral sensor that some of these drones have, it picks up light information from, so I guess the light that we see, the color that we see, is kind of a combination of these wavelengths of blue, green, and red that reflect off of objects, and the colors we see, like that green tree, it's reflecting a lot of green wavelengths of light that are in that green range. So that visible detection doesn't really help us, right? It takes a few years. But you notice this plot to the right here. There's the near infrared. Outside of this visible range, there's this near infrared, longer wavelength that, oh my gosh, there's a big distinction between healthy and unhealthy vegetation reflectance. And this is in vegetation studies, this near infrared range and red edge in between red and near infrared has been pretty valuable for folks who look at forest or vegetation health and vigor. And so using slapping a sensor onto a drone, and with this near infrared band wavelength and picking up light energy in that near infrared wavelength, might give us some information that we're not picking up with our eyes. That's kind of the idea here. My boss actually ran across this paper composed by a group out of the Czechoslovakia, the Czech Republic, I think it is now, that did this very thing on spruce trees. They were under attack by a different insect, but they said, hey man, we want to pick up this mortality before it's in our face. Let's make a drone. And they literally, they modified a drone and they made these multispectral sensors, and pretty creative and smart folks. It was some serious engineering power, but they put together this system, this multispectral system to fly, and they had success. They were able to make a model that picked out green attack trees. So this is all very exciting to us, and we came across the DJI Phantom 4 multispectral. This looks right up our alley. This is like an over-the-counter, ready-to-go ag drone. So no fancy engineering. This thing, it takes 6 pictures at once, and those bands, those little ranges of wavelength that can tell us some interesting things. Each one of these sensors has a narrow band of wavelength that it is capturing at each photo station. The cool thing about this probably looks familiar to you. This is a Phantom 4 body, which is a really popular recreational drone, or was. And so they're just they're bomber little machines, very stable, quadcopter, cheap to repair. But yeah, so we got thinking, man, we can apply this, maybe test this out on our spruce forest system here in South Central Alaska. The applications I see it used for right now are orchard stuff, mostly lots of citrus orchards or apple orchards, and they make some vegetation indices with the data coming from this drone, and they can pick up kind of tree level problems. So that's kind of the current application, but we want to test this out, see if it works for spruce and early detection of spruce beetle. The study site, got a convenient study site right here in Anchorage. It's Ruth Arcan Park, which is municipality ownership. And what I did was, starting in June of last year, I flew this site for 4 months until September. And about 15 acres, took me about an hour to fly. I had high overlap, but 2 battery changes. And I flew that same coverage 4 times. A little more detail here. The black crosses. I installed some ground control, and for those that don't know what ground control is, it's a target on the ground. It's a known point, high precision GPS collected points on this thing. I used the target that I set was a bucket lid, white bucket lid with black duct tape, which seemed to work just fine. I was flying at 90 meters and was able to find that in the imagery. But yeah, the GPS or the ground control points kind of spatially tighten up these reflectance maps that the software stitches together. The purple dots here you can see, or maybe you can't, but each one of these is labeled with a number, and in front of it either an H or an I. And these are little sample populations of trees. I took high precision GPS points of trees in the H, the healthy sample, which are mature white spruce that are green crowned, no attack sites on their bole whatsoever. And then the I sample population is, a seemingly healthy looking green crowned spruce. It's that green attack thing. It's got spruce beetle attack up and down the bole, and very obviously under attack by spruce beetle. Moving on to just an overview of processing. We use Pix4D Mapper, which is pretty user friendly. You know, like any software, you got to get used to it, but it kind of holds your hand through the whole thing. It's pretty simple. This is kind of a good representation of what you end up here. You got your red band, your blue band, your green band. These are reflectance maps that are mosaicked together as a final product for each one of the sensors. So this thing, as it flies and it stops and it takes an image, it takes 6 different pictures. The color composite's not on here, but and so you end up with 6 different maps of the scene you're flying. Also, you end up with a digital surface model, which can be valuable. After this initial step of tying key points together, you go in and you can integrate your ground control points. It's a little, point and click exercise and tightens up your map. And the last step here, which is I really like about Pix4D Mapper, it lets you do some raster math, or lets you make some vegetation indices, which is just a combination of those reflectance maps. And these indices can be helpful for, like I said, some vegetation studies. What we're trying to do is make a distinction between that attacked group and that healthy group. But NDVI, Normalized Difference Vegetation Index, is kind of a popular index for mapping vegetation in general, and some folks have applied it to vegetation health. You may have heard of it, but that's kind of the product we get here at the end. Now, limitations, is this thing truly radiometric? It's kind of a trick question. Yes and no, possibly, I don't know. It is not, you will not find this thing in the literature as of right now. And it is not, I've had some professors be like, this is not a research grade sensor, Clay. And what they mean by that is, there are some protocols for multispectral sensors. Fundamentally calibrating the thing with a calibration panel is something that is just commonplace in the research grade stuff. And that's a panel of some different looking blocks of color of known reflectance, and they calibrate their sensor with this, and it flies the scene and it comes back and it takes another picture of this thing, and you can make adjustments for changes in light and make those reflectance values absolute, so you can compare them to other reflectance values with different sensors. There's no calibration panel included in this workflow. Any sort of adjustments with sun angle and sunlight are made with this little cylinder up here, this little housing up here. With each photo station, it collects photos and then some information on sun angle and sun intensity. And in the processing, that is accounted for. And that's kind of the DJI black box. Don't really know the math on that, but angle and sun intensity are accounted for. The other thing is each of these sensors kind of has a wider range of capturing that wavelength than you would see in like a MicaSense research grade multispectral sensor. So this thing, it might collect a little more noise than you might like, but if your signal, if I'm looking for dead trees, I'm hoping that this thing is going to do what I want. So you just need to, I guess, be careful on what applications you use something like this for. For me, I'm using this as kind of a time series thing. I'm flying the same area several times, so these reflectance maps are comparable to each other and useful. But just a note on that, people will argue about if this is radiometric or not, and it really isn't. But does it do what we expect? It looks like it does. This figure on the left, I pulled from the literature, and it's just kind of a general, what you'd expect to see in reflectance, percent reflectance in different vegetation. So grass is really high reflectance in that near infrared wavelength. And broadleaf forests higher than conifer forests. And this is from Ruth Arcan Park. Here's a little desk exercise that I did, and I took some mean values of crown reflectance in the near infrared wavelengths, and it looks like hardwoods, they have higher overall reflectance than spruce, which are your conifers, and so that's to be expected. Looks like that's a good sign at least. Moving on, making some vegetation indices, and this is using the samples of healthy, the H down here, high precision GPS collected tree crowns, and the infected but green, the green attack trees. Greenness index showed some promise in the literature, but first look here, that's not too exciting. NDVI looks like it might do a little bit better, higher reflectance, less variance in the healthy group, and the infected sample looks like it might be all over the place. But this is the kind of thing moving forward, we're going to start testing out some ratios and indices to see if we can observe distinctions between these two groups. Here's just a visualization of the scene. Here's two sample crowns. They're both healthy, but I was just going to point out that you need to process your color composite here, because in these reflectance maps, certain edges and lines really don't show up. So I'm having to reference my color composite image, which is a part of that drone. One thing that does pop, you can see here, these bright white and whatever this is, teal. These are dead trees. On the color one, you see these red crowns here. They pop pretty nicely on some of these index reflectance maps. Yeah, moving forward, I guess I mentioned this already, but here's some different ratios and indices used for detecting dying trees. So we will probably apply these, probably get a bigger sample size, apply some vegetation indices and more than this. And when we find one that works, we're hopeful. Our intention is to build a model that can maybe give us some proportions of trees that are under attack, trees that are healthy, and dead trees. So I guess the full circle here is taking an over-the-counter drone that's really easy to use. You make a grid on your iPad of where you want to fly, send it up, it comes back in half an hour, and we're able to process this, maybe run it through a model, and get some pretty precise data on the health of these spruce trees in the wake of a spruce bark beetle attack, and make better informed decisions, especially in some fuels reduction applications. But I will zoom back to the front here so you can see my email. And feel free to reach out and comment or ask a question. And Nathan Lejeski's email is on here as well. He's my boss and the program manager for the forestry program at Chugach. But I'd love to hear from you. And that's about all I have. Thanks for the opportunity to present.
Good afternoon. My name is Brian Pitts. I work for BLM Alaska for Alaska Fire Service. I'm the Unit Aviation Manager, UAS Fire Coordinator for the military zone up here in Alaska. Currently held a UAS pilot license for the last 3 years. I'm carded on 4 aircraft and currently also carded for aerial ignition with the Drone Amplified's Ignis 2 PSD machine. This first slide here, I just want to briefly mention the NWCG Committee for Interagency UAS Aircraft Systems has a great website for people to go in, and it basically has all our guiding policy and guidance for unmanned aircraft systems and operations within the fire environment. It also has references, job aids, program updates, and training information. It also goes over the FAA Part 107 guidance and requirements. This slide is all the contacts that you will potentially need. I've included BLM, BIA, Forest Service, and OAS contacts. Any of these people be contacted anytime, and will more than likely be able to answer your questions or put you in the right direction. And up next is going to be a YouTube video on the UAS Interagency program that the national office in Boise put together, covering all aspects of UAS and fire. And after this presentation, I will be happy to answer any questions that you may have. Thank you.
The Interagency UAS program has been evolving rapidly over the last few years. The different missions that are provided have enhanced the agency's work in many ways. We will focus this discussion on its integration into wildland fire operations. There is an increasing need for the contracted Type 1 drones to perform intelligence, surveillance, and recon. The use of unmanned aircraft has proven to help incident management teams with live feed infrared during low visibility and night operations. Aerial ignition with the Ignis system is also in high demand. The implementation of UAS for aerial ignition is reducing exposure to personnel and is essential when poor visibility hinders manned aircraft. Today we have Gil Dustin, Justin Baxter, Matt Dutton, Adam Ridley, and Steve Stroud to explain the UAS positions and how they conduct operations safely.
There are a multitude of federal policies that govern the UAS program. We all work under the umbrella of the Federal Aviation Administration, or FAA. All of our interagency remote pilots are carded by the FAA as remote pilots under Part 107. We also have Department of Interior policy and U.S. Forest Service policy. The National Wildfire Coordination Group governs our operational standards, and for UAS we have a standards guide called the Interagency Fire Unmanned Aircraft Systems Standards. There are 4 UAS positions cataloged in our Incident Qualification and Certification System. They are UAS Manager, UAS Pilot, UAS Data Specialist, and UAS Leader. All 4 of these positions can be plugged in based on the scenario we have in play and the objectives we have for UAS on an incident. And I'm going to throw this over to Matt, and he's going to talk about our training and qualifications process.
When we think about the 4 UAS positions we use on incidents, wildfire incidents in particular, the pilot position is probably the position that we're utilizing most often, most heavily. Type 3 and Type 4 UAS, fly, situational awareness flights, IR flights, mapping flights. With the formal training through NWCG that we do have for our pilot is S373, which is Unmanned Aircraft Systems Incident Operations. And that training is really about safety of flight, operating on incidents in what we call the fire traffic area, integrating with manned aircraft, communicating effectively using the language that the manned aircraft expects on an incident.
The process of becoming a UAS pilot or any of the 4 positions that Gil had mentioned starts with becoming a remote pilot for the federal government. So it starts out with A450. Once you go through the A450 class and some IAT pre-work, that gives you the prerequisites to then start the process of becoming a UAS pilot.
So Matt and Justin, there's essentially 2 weeks of classroom training before you can actually go out on a fire and fly UAS. So is there any on-the-job or field training requirement before people are certified?
S373 training is pretty intensive field exercise-based training. Trainee pilots through a variety of scenarios that one might find on any incident. We like to integrate different incident mission profiles outside of wildfire to include search and rescue, investigations, etc. And successful completion of that training moves a pilot training into the next phase, which is kind of performance-based training on real-life incidents. So a task book is issued to trainees after they complete S373. So S373 is a knowledge-based class, and then with the field exercises that we use as kind of a practicum, successful completion of that leads to the task book, which pilot trainees take into the field and can use those task books on wildfires, prescribed fire, search and rescue, any incident. And those tasks that are identified in the task book are all performance-based and specific to what? What are we asking them to do in the task book?
Safely and effectively integrate UAS into the fire traffic area. So the tasks range from what needs to be done or what needs to be accomplished before you fly on an incident, all the way up into how to safely and effectively integrate UAS into a fire. So how to correctly speak to air attack or other cooperating aircraft, how to set up and deconflict before any sort of mission is undertaken.
So on one end of the spectrum, it's being able to use the radio and communicate to people on the ground, people in the air attack, helicopters, and manned aircraft. And then also how to use the aircraft itself, the GCS, set an altimeter, request flight areas and ceilings to operate in,
During S-373, we train our pilots to 4 different scenarios that they'll encounter on a wildfire or on an incident. One of which is there's no other aircraft in the area. The second is an aircraft shows up while they're in flight. The third is there's an aircraft on scene and how to coordinate and deconflict with an aircraft that's already working. And then the fourth, and probably most common, is that air attack is on scene. So the expectation as our pilots are working through their task book is that they're put into situations where they not only need to deconflict with other aircraft on scene where there is no supervision, but also working with air attack, with helibase, to make sure that we can ensure safety of flight and deconfliction. Starting the communication early is also key, but we all know that fire is a dynamic environment. So the plans that helibase has or the UAS pilots have at the morning briefings don't necessarily stay the priorities for the rest of the day. The number one thing that we want to do before we launch in airspace is make sure that we've communicated and deconflicted our airspace and what we're going to do. That starts with the UAS pilot calling helibase and letting them know when and where, how long we're going to be operating UAS. We do not expect helibase to do any sort of deconfliction for us, but we do want them to know where we're going to be operating because they're the ones that are going to send the helicopter up to do the next round of bucket work or the next crew shuttle. So inevitably, the message that we give to helibase of when and where we're going to be operating, what we're noticing or what we're seeing is that there is a gap in the current training for those positions that are either manning the radio or the expectation that we're putting on people that they haven't trained or seen before, that the message of when and where we're going to be operating isn't always passed on to the helicopters that are going to be out in the field. When air attack is on scene, that responsibility falls on air attack, and that I think they're used to operating in that capacity. What we've seen with the radio operator in the morning at helibase might be doing something else in the afternoon, and that message that we're operating is not getting passed from either one radio operator to the next, so they're either unaware that we're operating or it's just not something that they're trained on, that message needs to be passed to the helicopter before they launch.
And as we're figuring that out as pilots, I think we have a strong culture of doing what's right. As we continue to identify gaps, start to close those gaps through education, through training, and through integration of the element of an operational period that we're all contributing to.
We're here evaluating the Matrice 600 aircraft, Zenmuse XT2 DJI camera, and also the drone's amplified Ignis payload, which is a plastic sphere dispenser. So the ping pong balls, as they're commonly referred to, has a chemical in it called potassium permanganate, and when you inject the ping pong ball with glycol or antifreeze, you get a reaction about 30 to 45 seconds later. The reason we use ping pong balls is because we can drop it from the air. They ping pong down through the trees and get to the ground level so we can establish a backing fire, which generally, ecologically speaking, is more healthy for the forest, and it doesn't generate crown fire generally because we can control the intensity of the heat. If we start at the top and bring a line of balls across the top and then step that down the ridge, you create a less intense fire and just generally underburn the large fuel mass that's generated under however many years of conditions they've had since the previous fire. So that's really the intent. We're finding it beneficial because normally we have to hike people down the hill and either fire it by hand, which generates a lot more heat because it's more difficult to get up and down the slope, or we use conventional helicopter PSD machines. Problem with that is generally flying low and slow in hazardous conditions with a manned aircraft. It's very effective for landscape and being able to burn large areas if needed. This is more of a pinpoint precision tool, and also because of the forward-looking infrared camera, we can fly in essentially zero visibility where other aircraft can't fly, manned aircraft. So it's an excellent tool for what's called ISR, intelligence, surveillance, and recon, the ability to look at things when a manned helicopter flight recon isn't able, and they're also not able to fly in what's called instrument flight rules, IFR conditions. So we can fly essentially in zero visibility out to about 5 miles with this aircraft. So it's been very beneficial.
The way that we
start the firing. So we'll take the aircraft up, we'll fly it over to the location. For instance, this one we were flying from generally about this position here, which is about 1.25 miles away, and the altitude delta between the two is about 1,200 feet. So we were flying 1.25 miles, putting the aircraft at about 1,300 feet so that we're clear of any obstacles. The other nice benefit of this is you can see the white line that's out around the burn area. So that is what's called a geofence. So we can actually clear that geofence and we can build a new geofence. So if we just wanted to burn out this one drainage, we can geofence around a specific area. And then if the aircraft ever leaves that area, the Ignis machine will automatically stop dropping and give us a notification that we're flying outside of the geofence.
On the call when needed contract side of the house, better cameras, longer flight times. The aircraft are going to be flying either all day or all night. The idea is to launch them before the helicopters and everybody else spools up in the morning and bring them back into their base long after the air tankers, lead planes, and helicopters is left for the day. And I'd like to hand it over to our data specialist, Adam, to talk about some of the different products that we produce with contract UAS sensor packages.
Usually you're putting an aircraft up with some kind of product in mind, whether that's real-time situational awareness video, communication relayed directly to a division or branch. But depending upon the sensor package and the mission profile, we can produce a variety of different products. On the tactical side, we're talking more about real-time video that can be relayed directly to either ICP or with some additional technology personnel on the fire line directly. This is an example of an EO-IR mosaic that we built for the Skid Fire in New Mexico in 2019. This shows high-resolution daylight imagery on the left and high-resolution IR imagery on the right. They were processed separately, but as you can see, they match up pretty well. And we used the combined EO and IR imagery to derive a new fire perimeter for a fire that had previously not been mapped.
If you just have one takeaway, we'd like you to be aware that there is in fact an interagency fire UAS program, and these systems are out flying every day on fires.
Thank you to all of our presenters for those presentations. It looks like we've gotten a couple of questions asked in both the chat and the Q&A box, including one question that's in the Q&A box now with an answer is regarding FAA Part 107 requiring a minimum visibility of 3 miles to fly. Does fire have a waiver or special rules to be able to fly with a low or no visibility? Both Mark and Brian provided some answers regarding a minimum 3 mile visibility from the control station. That is not waivable. However, flying over a smoky area, the payload can let you see through the layer. So there's some additional comments and questions there. And our panelists will be opening up their videos shortly. Again, you can ask questions in the Q&A and we can answer those live. We already have some of those questions coming in. And then if anybody wants to ask a question directly, feel free to raise that hand. We can open up your phone line. While we're waiting to get some more of those questions or answers, do any of our panelists have anything they wanted to add or share with our participants?
Well, I just wanted to say thanks for the invite. I was happy to be able to make the presentation for you. And I know my contact information was up there briefly, and I will include my email address. If you ever have any questions, don't hesitate to reach out.
We also took a screen capture of Brian's great list of participants, so we can also share those as well.
Okay, yeah, excellent. I was gonna say it was pretty brief, and if anyone needed those contacts, feel free to contact me directly, or maybe we could get that from you, Stephanie.
Yeah. And it looks like we have a question in the question box from Clay. Are you able to draw a map locating the infected green trees on a tablet?
Well, I guess one thing I didn't mention that this drone does have, it has a live NDVI feed. So on your iPad, you can look at a color feed of your imagery as you're flying, and you're looking at this, and you can switch to an NDVI feed. So as you're watching your drone travel your grid, you can actually, you can move your camera around if you want to just go exploring, but you can go find those dead trees, those ones that on my presentation showed up in that bright white, or in the NDVI color scheme, I think it was like that teal. So you could just go capture NDVI live, but that's kind of, the data doesn't come through like it does when you process those individual bands. The goal for us is to eventually, be able to have a fire crew go and collect this data, and then I would have to process it still, but hopefully we can streamline this whole thing, because right now it's a bit messy. There's 3 different softwares involved, but hopefully it's something they can provide me with an SD card, and then I can make a map, maybe in a matter of hours or within a day, and turn it around and send them a map they can boot up on their tablet with, oh, here's a pocket of dying green trees, and these ones are healthy, so focus your energy on this part of the alignment, or maybe we don't even want to go this way because it's these are all good looking trees, and there's a dead stand over here. But so eventually I guess the goal is to have a workflow so we can process this data into a map on an iPad, and get these guys to walk around with an iPad with the information we got from the drone.
And it looks like we also have a follow-up question for you, Clay, regarding when you're flying at 90 miles out, do you have, or I might have gotten that metric wrong, 90M, do you have issues with tree distortions between images during the PIX 4D processing? I think you might have answered that, but I just want to double check.
Yeah, I did. I learned the hard way on this stuff a lot, but I noticed that some things I will do different is I was trying to, I guess our goal here is to try and make this a kind of a quick, streamlined process. And I would add more ground control. People say, I'm always flying 10 acres, and I had my professors and my advisors say, 4 or 5 ground control points. But if you, screw up and you fly it a little late in the day and shadow takes out that target or something, and you can't tighten up that map, those reflectance maps with that ground control, you get a lot of artifact and distortion with this machine. So at 90 meters, I think it's just making sure your ground control is visible and that you have enough ground control. But 90 meters for a little bucket lid, 5-gallon bucket lid, I was able to find the center of that. I just made a little duct tape diamond. So the resolution's there. It's just making sure that you can integrate ground control to tighten that up, because it needs a certain amount of key points to make sure you don't have a bunch of artifacts. Also, like I mentioned, the time of day was really important. If I had a lot of shadow, it didn't process very well at all. So making sure that I minimize shadow as much as possible. I had ground control. Those are really important. The trade-off with this machine is the sensor is an array of 6 cameras, so I haven't really tested it out, but I know the closer you get to the ground, each one of these reflectance maps that's processed off of each individual sensors is going to have a tougher time lining up and stacking on to each other, which is kind of the whole point of making these indices. You need those reflectance maps to be able to spatially be right on top of each other. So the closer you get to the ground, you're gonna have issues with having those individual reflectance maps lining up. But 90 meters has worked really well for me, given great conditions.
Great, Thank you for correcting the metrics. Brian, last question is to you. It's pretty quick. Are there any upcoming trainings for the A450 S373 coursework?
So as far as BLM training, there is one actually going on right now. They're in the second week doing the S373 part of the training up here in Alaska. Unfortunately, due to COVID regulations, it is only open to DOI and BLM employees. As far as other training going on, I know, the Forest Service does have contracts with private companies that are starting to conduct the A450 and 373 training. I don't know any going on in their near future, only because I haven't really been involved in some of the training. But if you go to that NWCG UAS Interagency website, that will give you some training dates and training locations. And if not, I would probably direct people to go to either the Forest Service contact, BLM contact, or the OAS contact for future trainings.